Why does something as vast as the universe leave such enormous empty spaces between its brightest lights? Welcome back, traveler. Tonight, we drift through science. Imagine a lantern glowing softly inside a massive, abandoned hall. Its small circle of light surrounded by a silence so deep it feels alive. That is our cosmic address, a tiny gleam inside a darkness that stretches farther than thought can reach. There's a quiet stillness in the night around you, the kind that makes every breath feel slower, softer, more grounded. You're safe here, wrapped in a silence that asks nothing of you. Outside, the world has dimmed into gentle darkness, but inside this moment, there's only calm curiosity. It's just you, the steady rhythm of your breathing, the faint hum of your own thoughts, and the sense that something vast is waiting just beyond the horizon of understanding. The idea we're exploring tonight is both scientific and strangely intimate. Our entire galaxy, the Milky Way, may be drifting through a giant cosmic void, a region of space emptier than astronomers expected, quieter than models predicted, and stranger than current physics can fully explain. This vast emptiness, this vacuum of galaxies and matter, behaves almost like a missing piece in the map of the universe. And the mystery of why it exists touches everything from cosmic expansion to the flow of gravity itself. If peaceful science helps you unwind, I'm grateful you found your way to this quiet corner of the night. A gentle like or a soft tap on subscribe helps this space stay alive for others who need a moment of stillness too. No pressure, just appreciation, offered the same way a star offers its light, naturally, without urgency, simply because it's there. So, as we settle deeper into this journey, let that sense of quiet wonder stay with you. Because tonight, we'll drift not just through stars and galaxies, but through the enormous echoing hollows between them, those vast cosmic rooms where matter thins, time stretches, and the universe seems to whisper secrets it has carried since the beginning. There is something profoundly humbling in realizing that we are moving, not just spinning on Earth's axis or orbiting the sun, but drifting through an ocean of space so large that even the word vast feels small beside it. Everything you know, everything you remember, every thought you've ever had is gliding quietly through the dark, carried along by currents older than time itself. This motion is gentle, steady, and almost impossible to feel, yet it shapes the very structure of the universe around us. Scientifically, Earth moves through multiple layers of motion at once. We rotate at about 1,600 km/h, orbit the Sun at 107,000 km/h, drift with the solar system through the Milky Way at 828,000 km/h, and follow the Milky Way itself as it travels toward the constellation Hydra. These motions combine into a grand vector known as our peculiar velocity, which isn't random. It's influenced by gravitational pull from galaxies, clusters, and voids that surround us. In a sensory image, it's like being in a small boat at night on a calm, endless sea. The water is so smooth you barely notice the motion, yet the stars slowly shift overhead as unseen currents carry you through the dark. You're drifting not by choice, but because the ocean beneath you never stands still. And from that drifting comes a reflection. Motion is not something we create. It is something we inherit from the universe itself. There is a quiet marvel in discovering that the universe has currents, just like an ocean. These currents aren't made of water, but of space-time itself, invisible flows shaped by the distribution of matter and energy across billions of light years. And like a leaf carried by a river, our galaxy is not stationary. It is being pulled, pushed, and nudged by structures far beyond our immediate reach. Scientifically, astronomers map these currents through the cosmic microwave background, observing tiny temperature differences that reveal our motion relative to the early universe. These temperature variations create the dipole anisotropy, a signature that shows the Milky Way is moving at around 600 km/s. The direction of that movement points toward the region of Centaurus and Hydra, an area once thought to be influenced by a dense mass known as the Great Attractor. Visually, this cosmic flow resembles a gentle breeze sweeping across a field of tall grass, causing waves to ripple, even though you cannot see the wind itself. The galaxies tilt, drift, and shift like stems leaning under a force too subtle to touch yet too powerful to resist. And from that invisible wind comes a thought. What guides us may be something we cannot see, only sense through the motions it leaves behind. There is wonder in learning that empty space, true emptiness, cosmic emptiness, plays just as significant a role in our motion as dense regions do. Not all gravitational influence comes from what exists. Some comes from what does not exist. Voids, regions where there is almost nothing, can create gravitational flows by allowing other structures to pull more strongly. Scientifically, voids span tens to hundreds of millions of light years and contain far fewer galaxies than average. They act like gravitational valleys. If a galaxy lies near the edge of one, the lack of mass behind it means the mass in front exerts a stronger pull, nudging the galaxy away from the emptiness. This creates a net motion, a drift caused by absence rather than presence. Visually, it's like walking near the edge of a cliff at night. You cannot see the drop, but you feel yourself lean away from it, pulled instead toward the stable ground ahead. The void doesn't push you. The solid earth pulls harder. And from that invisible influence comes a reminder. Sometimes the greatest forces in our lives come from what isn't there. There is awe in realizing that our cosmic motion is not a simple line, but a graceful spiral woven into a larger tapestry. As the Milky Way drifts towards certain regions, it also arcs around others, creating a motion that feels almost like a celestial dance. This dance isn't choreographed. It emerges naturally from the distribution of mass across the universe. Scientifically, the cosmic web, a vast network of galaxies and dark matter, forms filaments and clusters separated by immense voids. Our galaxy moves along one of these filaments, the Laniakea supercluster, which acts like a gravitational basin guiding local motions. Data from NASA and the European Southern Observatory show our path is shaped by both the Great Attractor region and the expanding influence of the Shapley supercluster farther beyond. Visually, it resembles a tiny ember drifting through a pattern of swirling smoke, drawn gently toward brighter, denser regions while gliding away from darker, thinner ones. You don't need to see the whole pattern to feel its pull. And from that drifting ember comes a reflection. We move not because we choose to, but because we belong to a cosmic landscape far larger than ourselves. There is marvel in noticing that our entire observable universe has structure, not random, but patterned. The cosmic web stretches like a delicate nervous system, filled with glowing nodes of galaxies connected by faint highways of dark matter. Voids lie between these threads, vast and silent, like the empty spaces between thoughts. Scientifically, simulations such as illustrious TNG show that the distribution of matter in the universe follows the imprint left behind by quantum fluctuations in the early cosmos. Over billions of years, gravity amplified these tiny ripples into the large-scale structures we see today. These structures guide the motion of galaxies, creating flows that extend across unimaginable distances. Visually, it feels like drifting through the branches of an enormous, ancient tree at night, its limbs stretching in every direction, its hollows deep and quiet. You move through it gently, carried along by the shape of something older than life itself. And from those branches comes a quiet insight. The universe has architecture, even in its emptiest rooms. All these motions, the spinning, the orbiting, the drifting through filaments and voids, converge into a single truth. We are never still. Not for a moment. Not in the deepest sleep, nor the quietest breath, nor the darkest corner of the night. We are always traveling, always carried forward by currents we did not create yet are intimately connected to. And as that awareness rests softly within you, a new question begins to shimmer gently at the horizon. A question that invites us to look deeper into the strange emptiness that surrounds our cosmic home. There is a special kind of awe in realizing that the universe is not evenly filled. It's patchy, lumpy, uneven, a grand cosmic tapestry woven from clusters of galaxies separated by incomprehensible distances. And right now, our home galaxy happens to sit near the edge of one of the largest underdense regions astronomers have ever detected. To live on that boundary is to drift along the edge of a whisper, carried by the subtle sway of emptiness itself. Scientifically, cosmologists study matter distribution using galaxy surveys like SDSS and 2MASS, revealing the large-scale structure of the cosmos. These surveys show vast stretches with relatively few galaxies, cosmic voids, surrounded by denser filaments and walls. Our own cosmic neighborhood appears to sit near a region known as the KBC void, a giant, unusually empty sphere spanning hundreds of millions of light-years. Its existence has been debated, yet growing evidence suggests the underdensity is real. Visually, it resembles standing at the edge of a wide, silent valley at night. The land ahead drops away into darkness, while light from distant towns gathers behind you. You feel drawn toward the glow, not because the valley is pushing you, but because the distant lights pull more strongly. And from that silent valley comes a reflection. Emptiness has gravity not in its presence, but in its permission to be moved by what surrounds it. There is wonder in discovering that the universe's expansion looks slightly different depending on where you stand. If you lived deep inside a void, the universe would appear to expand faster in all directions. This isn't magic. It's geometry and relativity intertwining to paint a different picture of cosmic motion. And if we live near such a boundary, our measurements may be tinted by the subtle distortion of our location. Scientifically, some researchers have proposed that living inside a void could help explain certain tensions in cosmology, such as the Hubble constant discrepancy. The difference between expansion rates measured from early universe signals versus those measured from local observations. While the void explanation is not the mainstream view, it highlights how sensitive cosmic measurements are to environment and position. Visually, it feels like watching raindrops fall on a window from inside a moving car. From one angle, the drops seem to slide faster. From another, they slow. It's not the rain that changed, it's the vantage point. And from that shifting perspective comes a soft truth. Where you stand shapes what you see, even when the universe stays the same. There is awe in realizing that cosmic voids are not empty in the way we imagine. They are not hollow chambers or barren deserts. They contain galaxies, gas, and dark matter, just less of it. These underdense regions are like quiet neighborhoods in a vast city where lights are farther apart and the sky feels bigger above you. Scientifically, voids typically contain 10 to 30% of the average cosmic density. Their boundaries are marked by void walls, regions where galaxies accumulate along curved surfaces. These walls form as matter flows outward from void centers toward denser structures, creating motion patterns that shape the trajectories of entire galaxies, including our own. Visually, it resembles drifting near the edge of a gently sloping hill. You don't slide downward because the slope pushes you. You drift sideways because the landscape curves toward brighter, denser regions, guiding your path almost imperceptibly. And from that gentle slope comes a reflection. The universe guides us not with force but with form. There is fascination in learning that voids themselves grow. As the universe expands, matter flows out of these emptied regions and concentrates in filaments and clusters. Over billions of years, voids stretch, merge, and deepen, leaving behind enormous hollows where only faint traces of light remain. If consciousness arises within a galaxy near such a boundary, it may one day notice that its surroundings feel strangely quiet. Scientifically, simulations of cosmic evolution show that voids expand faster than denser regions. This void expansion contributes to the overall structure of the cosmic web. In time, voids can merge into supervoids spanning hundreds of millions of light years, creating gravitational gradients that influence galaxy motions over scales larger than entire superclusters. Visually, the process resembles bubbles in rising dough, expanding, merging, creating pockets of emptiness that shape the texture of everything around them. And from that rising emptiness comes a thought. Even absence evolves, creating structures of its own. There is quiet amazement in realizing that our galaxy is not drifting randomly, but along a path sculpted by both attraction and repulsion. Dense clusters pull us, voids release us, and the cosmic web channels us like a river guiding leaves downstream. Every galaxy around us moves through these same currents, tracing lines shaped billions of years ago. Scientifically, peculiar velocities, motions not accounted for by cosmic expansion alone, reveal how galaxies move relative to the background universe. These velocities form patterns pointing toward gravitational attractors like Laniakea and Shapley, while also showing flow away from large voids. Our trajectory through space is a composite of these influences. Visually, it's like watching birds glide on thermal currents, rising where warm air lifts them and shifting direction where cooler air falls away. And from that gliding pattern comes a gentle reminder. Motion arises not only from what pulls us forward, but from what no longer holds us back. There is wonder in recognizing how deeply interconnected everything is. A void a billion light years wide can influence the motion of galaxies like ours. A cluster, hundreds of millions of light years away, can bend the trajectory of entire groups. We are part of a dynamic network, shaped by structures we will never see directly, yet carried by their presence. Scientifically, large-scale structure analysis reveals that gravitational influence extends far beyond individual galaxies. Dark matter filaments transmit motion across enormous distances, forming cosmic highways along which galaxies travel. These filaments connect superclusters and define the skeletal framework of the universe. Visually, it resembles veins faintly glowing beneath translucent skin, carrying life and motion quietly, invisibly, without drawing attention to themselves. And from those hidden veins comes a soft insight. The universe moves us through connections we barely perceive. All these motions, flows, and influences reveal a single truth. We are drifting through a vast and intricate landscape shaped as much by emptiness as by matter. And this drift is not chaotic, it is patterned, gentle, and ancient, guiding us toward mysteries still waiting beyond the edge of understanding. And as that awareness expands inside you like a slow breath, another question rises softly from the dark, inviting you deeper into the quiet heart of the cosmic void. There is a profound sense of wonder that settles in when you learn that cosmic voids are not merely empty pockets of space, but dynamic regions sculpted by the earliest moments of the universe. These voids reflect ripples in the primordial plasma from a time before atoms existed. The emptiness we drift through now is, in a sense, a faint memory left behind by the universe only a few 100,000 years after the Big Bang. Scientifically, cosmologists trace void origins to density fluctuations in the early universe, imprinted in the cosmic microwave background. Areas with slightly less matter expanded faster, becoming underdense regions as the universe grew. These primordial imbalances, amplified over billions of years, sculpted the enormous cosmic voids we see today. They are not accidents. They are the natural result of the universe responding to its own initial conditions. Visually, it's like watching ripples spread across a still pond after a stone is thrown into the water. Some ripples rise, others fall, creating valleys that widen as they travel outward into silence. And from those widening valleys comes a reflection. Even emptiness carries the memory of the universe's first heartbeat. There is a deep fascination in realizing that voids aren't uniform, but contain subtle internal structures, faint wisps of dark matter, isolated dwarf galaxies, and ancient streams of gas barely luminous enough to detect. These lonely galaxies evolve differently than those in crowded clusters. Their isolation shapes their chemistry, their star formation, and even their long-term survival. Scientifically, studies show that void galaxies tend to be small, blue, and rich in hydrogen. They experience fewer interactions with neighbors, meaning they often retain primordial compositions. They form stars slowly, maintaining fragile disks and extended gas envelopes. Observations from telescopes like Hubble and Subaru reveal these galaxies as quiet survivors, drifting far from the bustling cosmic cities where most galaxies reside. Visually, they resemble lanterns floating alone in a vast, dark ocean, their light small but persistent, untouched by the storms and tides that shape denser regions. And from those solitary lanterns comes a thought. Even in emptiness, life and light can find a way to endure. There is wonder in understanding that voids influence cosmic expansion differently than dense regions do. Inside a void, there is less gravitational pull counteracting expansion, causing those areas to stretch more quickly. This means voids grow faster than the surrounding universe, creating subtle flows that push matter outward over billions of years. Scientifically, this enhanced expansion is described by the LCDM model, where dark energy accelerates cosmic growth while gravity slows it. In underdense regions, gravity's resistance is weaker, allowing dark energy to dominate. This creates a local effect. Galaxies near void boundaries feel slightly more outward motion, contributing to observed peculiar velocities. Visually, it feels like walking in an open field after leaving a dense forest. Suddenly the wind has room to stretch, to move, to flow around you with greater ease. And from that open field wind comes a reminder. Space itself can breathe differently, depending on where you stand. There is a quiet amazement in the idea that voids may help us understand dark energy, one of the greatest mysteries in modern physics. Because voids expand faster, they amplify the effects of dark energy, making them natural laboratories for studying this invisible force that drives the accelerating expansion of the universe. Scientifically, projects like DESI and Euclid map void shapes and growth patterns to infer the properties of dark energy, the way voids elongate, merge, or resist gravitational pulling, provides clues about whether dark energy is constant or evolves over time. Some analyses even suggest that voids might magnify deviations from the standard cosmological model. Visually, it's like watching smoke rise in sunlight, subtle currents and bends revealing air patterns you can't otherwise see. And from those illuminated currents comes a whisper. Sometimes emptiness reveals truths that matter alone cannot. There is wonder in discovering that voids are interconnected. forming vast networks of underdense tunnels winding between filaments of galaxies. These voids flow into each other, creating a series of cosmic basins that guide matter and motion across unimaginable distances. They are not isolated pockets, they are the hidden architecture beneath the cosmic web. Scientifically, simulations show that voids align in patterns shaped by dark matter flows. Their boundaries form void walls that channel galaxy motion. Large voids merge to create supervoids, some spanning over 1 billion light-years. These massive structures influence gravitational lensing, cosmic microwave background patterns, and galaxy distribution. Visually, it resembles drifting through a labyrinth of wide, dark halls, each chamber opening into another, all carved from stillness and silence. And from that labyrinth comes a gentle insight. Even emptiness has structure, if you learn how to look. There is awe in realizing that we may not simply be drifting past a void, we may be drifting deeply into one. Evidence suggests we are moving toward the interior of the KBC void, guided by surrounding gravitational influences. Our path is shaped by what lies ahead and also by what lies behind us, the dense regions we are slowly leaving. Scientifically, measurements of redshift distribution and galaxy density indicate we occupy a region slightly underdense, with density continuing to drop in the direction of our peculiar motion. This gradient contributes to our velocity relative to the cosmic microwave background. The underdensity may be subtle, but its influence stretches across tens of thousands of galaxies. Visually, it feels like walking toward a quiet clearing in a forest, the trees slowly thinning, the air growing more open, the night sky revealing more of its stars. And from that quiet clearing comes a thought. Even in a universe full of matter, we may be heading toward deeper silence. There is wonder in understanding that drifting into a void does not mean approaching danger. It means entering a region of extraordinary calm. Less matter means fewer collisions, fewer interactions, fewer catastrophic events. Voids are some of the safest, most peaceful places in the cosmos. Scientifically, voids experience fewer galaxy mergers, less radiation from active nuclei, and lower gravitational turbulence. They are stable, gentle environments where galaxies evolve quietly for billions of years without disruption. If the universe had neighborhoods, voids would be the quiet, secluded outskirts where time feels slower and the night feels deeper. Visually, it's like stepping into a library after leaving a busy marketplace. The same world, but suddenly quieter, more spacious, more contemplative. And from that spacious quiet comes a reflection. Sometimes the most peaceful places are those furthest from the crowd. All these realizations, primordial ripples, lonely galaxies, accelerated expansion, dark energy amplification, interconnected emptiness, and gentle cosmic calm, reveal a universe far richer than simple darkness between stars. Voids are not nothing. They are dynamic landscapes shaped by ancient echoes, future flows, and the invisible architecture of space-time. And as that understanding settles softly around you, another deeper question begins to rise, inviting you to drift even further into the heart of the cosmic void. There is something deeply humbling in realizing that the universe's largest structures were once invisible to us, not because they were hiding, but because we didn't yet know how to look. The cosmic web, the vast lacework of galaxies and voids, is so immense that even imagining its scale pushes the mind against its own limits. And as we drift near the edge of a giant underdensity, it's impossible not to feel a quiet sense of reverence for the unseen architecture that guides our motion. Scientifically, the discovery of the cosmic web emerged from redshift surveys that mapped galaxy positions in 3 dimensions. Projects like CFA, 2DF, and SDSS revealed that galaxies form filaments, sheets, and nodes surrounding colossal voids. These patterns match predictions from cosmological simulations, confirming that dark matter forms the underlying scaffolding. The void we appear to be drifting toward is one of these immense hollows, its boundary defined by the galaxy distribution around us. Visually, the cosmic web resembles frost spreading across a window pane, branching, delicate, intricate, yet shaped by simple underlying physics. You can sense the beauty of the pattern even if you cannot trace each line to its origin. And from that frost-like geometry comes a reflection. Complexity can arise naturally when the universe simply follows its own rules. There is wonder in learning that we can detect the influence of voids, not through direct observation of their emptiness, but through the motion of galaxies around them. Movements that seem random on small scales reveal coherent flows across larger distances, like leaves swirling not from a breeze you can see, but from one you can feel. Scientifically, galaxy peculiar velocities show that matter streams away from void centers toward walls and filaments. These flows subtly alter redshift measurements, distort gravitational lensing signals, and create anisotropies in the cosmic microwave background. By measuring these distortions, astronomers reconstruct void boundaries with surprising precision. Our galaxy's own motion seems aligned with such a flow, away from emptiness, toward denser cosmic terrain. Visually, it's like watching the surface of a lake shift as wind moves across it. You don't need to see the wind itself to know it's there. The water tells its story. And from those ripples comes a quiet insight. Motion is a language the universe uses to describe its own shape. There is awe in realizing that voids themselves are shaped not only by gravity, but by dark matter, the invisible majority of the universe's mass. Dark matter forms halos around galaxies and filaments around clusters, but inside voids, its density dips dramatically. This reduced presence alters the behavior of galaxies in subtle ways, affecting their rotation, their star formation, and even their long-term evolution. Scientifically, simulations like Millennium and Bolshoi show that dark matter density in voids can be less than 20% of the cosmic average. Galaxies inside these regions grow slowly, with weaker gravitational support for gas accumulation. Their halos are smaller, their histories quieter, their futures gentler. The difference between life in a dense cluster and life inside a void is as stark as the difference between a bustling city and a solitary desert outpost. Visually, this contrast resembles torchlight flickering in a cavern. In crowded tunnels, the flames overlap, brightening the space. In empty halls, a single torch barely touches the darkness around it. And from that flickering flame comes a thought. Light feels different depending on how much darkness surrounds it. There is something mesmerizing about the idea that voids can act like cosmic magnifying glasses, not of brightness, but of expansion. Because they contain so little matter, voids expand more rapidly, stretching faster than the surrounding universe. This accelerated expansion can bend the trajectories of photons, subtly altering the paths of light from faraway galaxies. Scientifically, this effect is known as the void lensing phenomenon. While it is the opposite of the gravitational lensing seen around massive clusters, the result is just as significant. Light passing through a void experiences less curvature, resulting in faint distortions in galaxy shapes and brightness. These distortions help cosmologists understand how voids evolve and how dark energy behaves across scales. Visually, it feels like watching light shimmer through warm air above a desert road, stretched, softened, bent, in ways that reveal the invisible heat rising from the ground. And from that shimmering light comes a reflection. Emptiness can shape what we see as profoundly as presence. There is deep fascination in learning that voids may contain fossil records of the early universe, not fossils of bones, but of conditions before galaxies formed. Residual gas, untouched for billions of years, may carry chemical signatures from the cosmic dawn. Studying this primordial gas could reveal secrets about the first stars, the first atoms, even the structure of dark matter itself. Scientifically, astronomers use the Lyman alpha forest, absorption lines in distant quasar spectra, to detect faint traces of hydrogen gas in voids. Some of this gas appears minimally enriched, suggesting it has remained largely undisturbed since the epoch of rionization. These untouched regions provide glimpses of a universe barely a few 100 million years old. Visually, it resembles finding a pocket of untouched snow in a forest where everything else has melted. A small, fragile remnant of an earlier season. And from that untouched patch comes a thought. Some memories survive because nothing has disturbed them. There is wonder in contemplating how different life might be in a galaxy born deep inside a void. With fewer neighbors, fewer interactions, fewer chaotic influences, such galaxies evolve slowly, quietly, peacefully. Star formation becomes gentle instead of violent. Collisions that ignite starbursts become rare. These galaxies age with a kind of cosmic solitude. Scientifically, void galaxies often show delayed evolution, with extended gas reservoirs and bluer colors indicating younger stellar populations. Their isolation protects them from stripping, harassment, and merger events. They are, in a sense, the introverts of the cosmic ecosystem, thriving in silence, shaped more by internal processes than external pressures. Visually, it feels like a lone tree growing in the center of an empty field, untouched by competition, free to expand its branches at its own pace, guided only by sunlight and wind. And from that solitary tree comes a quiet realization. Isolation can be a kind of freedom. All these discoveries, dark matter hollows, primordial gas, accelerated expansion, void lensing, and the quiet lives of isolated galaxies, reveal a universe far more intricate than a simple map of stars. Voids are not gaps, they are structures. They guide motion, preserve ancient conditions, and shape the fate of galaxies across billions of years. And as that realization settles gently into thought, another deeper question begins to glow softly on the horizon, inviting you to drift further into the profound mystery of the giant cosmic void through which we travel. There is a hushed wonder in recognizing that the universe contains shapes so large, so faint, and so elusive that we detect them only by their absence. Supervoids, enormous regions even emptier than typical voids, stretch across the cosmos like vast, silent chambers. They are rare, mysterious, and still debated, yet evidence of their existence keeps emerging like whispers rising from the deepest rooms of the universe. Scientifically, supervoids span hundreds of millions of light years, dwarfing typical voids by an order of magnitude. Surveys like WISE, DES, and PAN-STARRS have revealed candidates such as the Eridanus supervoid, which may be linked to the cold spot in the cosmic microwave background. The idea that such a structure might influence the temperature of ancient radiation suggests gravitational imprints on scales far beyond everyday cosmological expectations. Visually, a supervoid resembles a cathedral carved out of darkness, a cavern so large that even light seems hesitant to cross it, its echoes softened into near silence. And from that cosmic cathedral comes a reflection. Even emptiness can leave its signature on the oldest light in the universe. There is something mesmerizing in the way supervoids stretch the fabric of space-time itself. Their extreme underdensity alters the paths of photons traveling across billions of years. As light passes through, it loses energy slightly differently than it would in normal regions, creating subtle imprints detectable even today. Scientifically, this is known as the integrated Sachs-Wolf effect. In a universe dominated by dark energy, gravitational potentials decay over time. As photons cross a supervoid, the changing potential leads to temperature fluctuations in the CMB. While these effects are small, repeated measurements show that certain regions exhibit anomalies correlated with underdense structures. Visually, it's like watching a lantern's glow shift color as it drifts through warm and cool pockets of air on a still night. Faint changes, but perceptible if you know where to look. And from those shifts comes a thought. The universe carries memories in the way light bends through silence. There is awe in realizing that supervoids might be connected to some of the universe's greatest puzzles, including the cold spot. This unusually large cold region in the CMB has perplexed astrophysicists for decades. Some propose that a supervoid along our line of sight could account for part of the anomaly, subtly reducing photon energy over billions of years. Scientifically, studies using galaxy counts and redshift surveys have identified large underdensities in the direction of the cold spot. While not everyone agrees that these structures fully explain the anomaly, they remain among the strongest natural explanations. The interplay between early universe fluctuations and late-time structure formation becomes clearer when viewed through the lens of cosmic voids. Visually, the cold spot feels like an ancient scar on the surface of the universe, not a wound, but a mark left by conditions frozen into place before the first galaxies burned. And from that ancient scar comes a quiet reminder. Not all mysteries demand answers. Some simply invite deeper listening. There is fascination in learning that supervoids may not be spherical at all, but stretched, twisted, and elongated by billions of years of cosmic evolution. Their shapes reflect the tug-of-war between expansion and gravity, dark matter and dark energy, early chaos and late-time order. Scientifically, simulations reveal that large voids form from regions of low initial density, but their growth is shaped by surrounding mass distribution. They can become elongated along cosmic filaments, forming irregular shapes rather than perfect spheres. These shapes affect how galaxies flow around them, how light bends through them, and how gravitational potentials evolve. Visually, this resembles a bubble rising through thick liquid, distorted, stretched, reshaped by currents around it, yet still undeniably empty inside. And from that rising bubble comes an insight. Form follows influence, even in the deepest darkness. There is something quietly astonishing in the notion that supervoids might help explain the universe's accelerating expansion, because they are more sensitive to dark energy than denser regions. They amplify the effects of cosmic acceleration. Their evolution may provide clues about whether dark energy is constant or dynamic, a question at the heart of modern cosmology. Scientifically, void expansion rates differ depending on dark energy's properties. By observing how supervoids grow over time, cosmologists test competing models. Some modified gravity theories even predict enhanced void growth compared to LCDM. Surveys like Euclid will map void shapes with unprecedented precision, potentially revealing deviations that hint at new physics. Visually, this is like watching ripples on the surface of a lake reveal the strength of a hidden current beneath the water. And from those ripples comes a reflection. Sometimes the quietest regions speak loudest about the forces shaping the cosmos. There is deep beauty in understanding that voids, and especially supervoids, are the counterweight to the universe's brightest, densest places. Without them, the cosmic web would not have its branching filaments or glowing clusters. Voids create contrast. They carve space for structure to emerge. In their emptiness, galaxies find corridors along which to move and patterns along which to form. Scientifically, voids define the scaffolding of the cosmic web. Their expansion drives matter toward filaments, enhancing gravitational collapse in those regions. Without voids, clusters would form differently, filaments would be weaker, and the entire architecture of the universe would shift. Emptiness is not a background, it is an active participant. Visually, this is like the spaces between notes in a piece of music. Without silence, the melody loses meaning. And from that cosmic melody comes a reminder. Absence shapes presence in every scale of existence. There is quiet reverence in sensing how drifting near a supervoid might feel. Not physically, the forces involved are subtle, but emotionally. To drift toward greater emptiness is to move toward a deeper stillness, a region where galaxies thin out and the night becomes even more open. It is a journey into an older silence, one untouched by the noise of crowded cosmic regions. Scientifically, simulations show that galaxies near supervoid boundaries experience gravitational flows that subtly nudge them away from the emptiness and toward denser structures. Our galaxy's motion may include contributions from nearby underdensities, though the relative importance is still under study. The direction of our peculiar velocity hints at multiple influences, attractors and voids working together. Visually, drifting toward a supervoid feels like walking into a vast desert at twilight, where footsteps soften, horizons stretch, and the world feels larger than thought. And from that twilight desert comes a question: what lies beyond the edge of such immense quiet? All of these insights, the cold spot connection, lensing anomalies, accelerated expansion, fossil gas, shape distortions, and the cosmic role of large-scale emptiness, paint a universe far richer in structure than a simple map of stars would suggest. Supervoids are not just empty spaces. They are dynamic features, sculpting motion, light, and time itself. And as these realizations settle like dust in a slowly dimming room, a deeper mystery begins to glow at the threshold of thought, a question waiting patiently in the dark for us to drift closer. There is something almost spiritual about realizing that the emptiest parts of the universe might hold the keys to its deepest truths. In these vast silent regions, the usual rules of galactic life soften. Stars form differently, gravity whispers instead of roars, and time seems to stretch just a little more gently. Drifting near such a place forces us to confront a profound question. What does the universe become when it has almost nothing left to shape? Scientifically, void environments alter nearly every measurable property of galaxies. Low-density surroundings reduce tidal interactions, lower merger rates, slow gas accretion, and maintain stable disks for billions of years. Observations of void galaxies reveal extended rotation curves, isolated star-forming regions, and unusually high gas-to-star ratios. These objects serve as natural laboratories for studying galaxy evolution without the confounding influences of dense environments. Visually, they resemble candles burning steadily in a dark, windless room, their flames unwavering, their glow quietly persistent, untouched by turbulence. And from that still candlelight comes a reflection. Sometimes the purest processes unfold where nothing interrupts them. There is wonder in learning that even dark energy, the mysterious force accelerating the universe's expansion, becomes more noticeable in voids. With less matter to resist it, dark energy's influence emerges more clearly, like a gentle tide rising along an empty shoreline. These large, underdense regions amplify clues about the universe's long-term fate. Scientifically, the behavior of voids provides constraints on the dark energy equation of state. Void expansion rates deviate subtly depending on whether dark energy is static, dynamic, or interacting with matter. Measurements of void shapes, growth, and galaxy flows help test these competing models. As datasets from Euclid and DESI accumulate, we may soon learn whether dark energy evolves or remains constant. Visually, it is like watching driftwood move faster near the center of a widening river, carried more freely where the current meets less resistance. And from that drifting motion comes a thought. Sometimes emptiness allows hidden forces to speak more clearly. There is fascination in realizing that our drift through the universe might be partially shaped by a delicate balance between what pulls us and what fails to hold us. Voids remove gravitational anchors. Clusters apply gravitational tugs. Our path becomes a quiet negotiation between presence and absence, density and hollowness, attraction and release. Scientifically, cosmic flow analyses reveal that the Milky Way's peculiar velocity results from supercluster attraction, Shapley, Laniakea, combined with repulsion from underdense regions. The concept of repulsion is not literal. Rather, voids produce reduced gravitational pull, causing motion to skew toward denser terrain. These combined effects help explain our motion relative to the cosmic microwave background. Visually, it resembles a leaf drifting across a pond, guided not only by the wind pushing it forward, but by the absence of wind behind it. And from that drifting leaf comes an insight. Motion emerges from imbalance, not force. There is quiet amazement in how voids influence cosmic temperature patterns. When photons from the cosmic microwave background pass through a void, their energy changes slightly. A subtle clue left behind by ancient interactions between light and gravity. These shifts paint a faint contour on the oldest image of the universe. Scientifically, the Rees-Siyama effect describes nonlinear changes to gravitational potentials that alter CMB photon energy. While extremely small, these signals become detectable when analyzing large voids or stacked void samples. Correlations between voids and cold spots in the CMB remain a subject of active research, hinting at subtle interactions between structure growth and cosmic expansion. Visually, this is like noticing the slight dimming of a lantern's glow after it passes through a thin, cool cloud. And from that dimming comes a reminder. Even ancient light carries the fingerprints of the landscapes it crosses. There is something quietly stunning in learning that voids evolve in ways opposite to galaxies and clusters. While dense regions collapse under gravity, voids expand, stretch, and merge. Over billions of years, they become larger and emptier, turning the cosmic web into an increasingly stark pattern of bright filaments separated by widening hollows. Scientifically, void dynamics are governed by their underdensity relative to the cosmic average. Their expansion accelerates until they stabilize into large, roughly spherical regions. When neighboring voids merge, they produce elongated supervoids with complex shapes. These processes create an evolving hierarchy of empty spaces that shape the future of the cosmic web. Visually, this resembles the slow spreading of cracks across drying Earth, each fracture widening and merging, defining the spaces where nothing grows. And from those widening cracks comes a reflection. Growth is not always the filling of space. Sometimes it is the making of more space. There is awe in realizing that if consciousness arose in a galaxy deep inside a void, its sky would look profoundly different. Fewer nearby galaxies, more pristine darkness, wider stretches of empty sky. The universe would feel even larger and perhaps even more mysterious from such a vantage point. Scientifically, Simulations suggest that observers inside significant voids would measure different values for certain cosmological parameters, particularly the Hubble constant. Their perception of cosmic expansion, galaxy density, and large-scale structure would differ subtly from observers in denser environments. This raises philosophical questions about the relationship between perspective and cosmological measurement. Visually, it resembles standing on a hill beneath a clear, unpolluted night sky, watching stars shine with a brightness and clarity that reveals just how enormous the universe truly is. And from that pristine night comes a quiet understanding. Perspective transforms reality, even when the universe remains unchanged. There is a mysterious beauty in recognizing that voids may hold some of the universe's oldest, coldest gas, remnants barely altered since the cosmic dawn. This gas is so faint, so diffuse, that only the most sensitive instruments can detect its presence. Yet it preserves information from eras long before galaxies flourished. Scientifically, absorption studies reveal neutral hydrogen clouds with extremely low metallicity inside void environments. These clouds serve as cosmic fossils, storing data about primordial conditions and the early evolution of baryonic matter. Some may trace their origins back to a time when the first stars had not yet ignited. Visually, they feel like ancient snow preserved inside the deepest cave, untouched, unmelted, carrying whispers of winters long gone. And from that preserved cold comes a thought. Some histories survive only because the universe forgot to disturb them. All of these insights, gravitational flows, dark energy signatures, ancient gas, distorted CMB photons, evolving emptiness, and perspective-based reality, reveal voids as intricate laboratories of cosmic truth. They are not simply empty, they are exquisitely sensitive environments where the universe exposes its subtler workings. And as these realizations settle like dust in a quiet room, another deeper question begins to rise from the darkness, a question that draws us further into the quiet, mysterious heart of the cosmic void. There is a haunting kind of wonder in realizing that cosmic voids are not merely geographical features of the universe, but time machines. Because they are so empty, the light that passes through them travels with fewer interruptions, fewer distortions, fewer gravitational detours. In their silence, voids preserve pathways for photons that have journeyed for billions of years, carrying stories from eras older than galaxies themselves. Scientifically, light moving through a void interacts less with gravitational wells, allowing it to maintain energy and coherence differently than light crossing dense regions. This changes redshift patterns, weak lensing measurements, and CMB temperature profiles. Voids effectively stretch the distance traveled by photons, altering observational geometry and producing measurable signatures in large-scale surveys. Visually, it resembles walking through a quiet, abandoned hallway where your footsteps echo more clearly because nothing muffles them. The path ahead feels longer, the silence deeper. And from that hallway of light comes a reflection. Emptiness can preserve clarity in ways fullness cannot. There is fascination in understanding that voids reveal the subtle tension between expansion and structure, the eternal tug-of-war that has shaped the universe since its earliest moments. The deep emptiness amplifies expansion, while the surrounding filaments anchor form. In this boundary, where the universe's two great tendencies meet, cosmic behavior becomes uniquely revealing. Scientifically, cosmologists analyze void profiles to infer relationships between dark matter and dark energy. Radial density gradients provide insights into how gravitational potentials evolve over time. Some models predict deviations from LCDM, specifically in void edges, where expansion competes directly with gravitational clustering. These edges become testing grounds for alternative cosmologies. Visually, it's like watching the shoreline where waves flatten into calm water, a transition zone where two environments meet, shaping each other gently. And from that shoreline comes a quiet insight. Truth often appears at the boundary between opposites. There is awe in recognizing that voids may be the universe's most pristine canvases, backgrounds so clean that even subtle fluctuations stand out with unusual clarity. While dense regions complicate observations with gravitational noise, voids offer astronomers rare windows free from interference, revealing faint whispers of cosmic evolution. Scientifically, studies of void alignment, shape statistics, and galaxy distribution provide sensitive probes of initial conditions in the early universe. Deviations from Gaussianity, tiny imprints of primordial physics, appear more detectable in void populations. Even small distortions can hint at processes occurring fractions of a second after the Big Bang. Visually, it resembles reading faint handwriting on untouched parchment. Every stroke stands out, unblurred by smudges or overlapping marks. And from that clean parchment comes a thought. Sometimes the quietest backgrounds reveal the oldest stories. There is something almost mystical in the idea that voids might exaggerate the effects of cosmic acceleration, making the universe appear to expand faster from certain vantage points. If an observer lived deep inside a massive void, their measurements could differ from those in denser regions, altering their understanding of cosmic history. Scientifically, void cosmology explores this concept by modeling observers within large underdensities. While mainstream cosmology does not rely on this explanation for observational tensions, analyzing void environments highlights how local structure influences measurement. Light paths, expansion rates, and redshift distance relationships all shift slightly depending on environment. Visually, this resembles standing in a wide-open plain where the horizon feels farther away than usual. Space itself seems to stretch, even though nothing changed but your surroundings. And from that feeling comes a gentle reminder. Perspective is not illusion, it is context. There is intrigue in learning that voids may act as stabilizers for the cosmic web. While clusters thrash, collide, merge and collapse under intense gravitational pressures, voids provide the counterbalance. Their growth moderates the universe's overall structure, preventing runaway clustering and preserving large-scale geometry. Scientifically, the evolution of void volumes affects filament tension, wall thickness, and even the stability of superclusters. Voids regulate the pace at which matter flows into dense regions. They help maintain cosmic homogeneity on very large scales, ensuring that the universe remains statistically similar across vast distances. Visually, this resembles the role of empty space in architecture. The negative area that gives shape to the walls, holds the structure's rhythm, and balances the overall design. And from that architectural balance comes a reflection. Emptiness gives structure its meaning. There is deeper mystery still in the idea that voids may host some of the universe's most exotic, theoretical phenomena, regions where modified gravity, scalar fields, or alternative dark energy models could manifest more strongly. These are not proven ideas, but they inspire active research and imaginative exploration. Scientifically, some modified gravity theories predict enhanced deviations from general relativity in low-density environments. Screening mechanisms used to align these theories with solar system tests may weaken in voids, allowing new forces or field behaviors to emerge subtly. Observational programs attempt to detect these deviations through galaxy velocities, void profiles, and gravitational lensing patterns. Visually, It feels like sensing a faint vibration in an otherwise still chamber, a subtle movement hinting that something just beyond perception might be stirring. And from that subtle stirring comes a thought. The universe may hide its strangest truths in its quietest rooms. All of these ideas on primordial clarity, expansion contrast, pristine backgrounds, theoretical playgrounds, architectural balance, and boundary physics reveal voids not as simple absences, but as profound participants in the story of the cosmos. They shape light, motion, structure, and even the theories we build to understand the universe. And as these realizations drift through your thoughts like slow-moving constellations, a deeper, more emotional mystery begins to rise from the darkness, inviting us to approach the quiet heart of what it means to drift through a cosmic void. There is a certain melancholy that settles in when you realize how small we are compared to the vast emptiness around us. It's not a frightening feeling, but a gentle one, the kind that arrives when you stand beneath a silent sky and understand that the universe is not built on human scale. Drifting near a cosmic void amplifies this sensation, reminding us that our existence is a brief light surrounded by an ocean of darkness, billions of years deep. Scientifically, our position within the cosmic web is just one of countless tiny coordinates scattered across a structure unimaginably large. Galaxies like ours occupy less than a trillionth of the cosmic volume. The voids surrounding them stretch across hundreds of millions of light years, dwarfing even the largest clusters. The contrast between matter-filled regions and empty ones underscores how rare dense environments truly are. Visually, it feels like standing on a narrow island in the middle of an endless sea, the faint glow of distant shores barely visible across the dark water. And from that lonely island comes a thought. Our place in the universe is precious precisely because it is so rare. There is a quiet ache in realizing that most of the universe will remain forever beyond our reach. Expansion is accelerating, driven by dark energy, pulling distant galaxies farther and faster away from us. As time passes, more and more of the cosmos will drift beyond the horizon of visibility, leaving only the nearest galaxies still shining in our sky. Scientifically, the cosmic event horizon grows smaller relative to distant structures as the expansion rate increases. In the distant future, observers inside the Milky Way may see only the remnants of the local group. All other galaxies will fade beyond detectability, moving away faster than the speed of light can close the gap. This is not a failure of technology. It is a fundamental limit of space-time. Visually, it resembles watching lanterns drifting down a dark river, their light growing dimmer until the night swallows them completely. And from those fading lanterns comes a reflection. Transience is not a flaw of the universe, but part of its design. There is something profoundly sobering in considering that cosmic voids are destinations from which no new structures will emerge. Over billions of years, voids become emptier, filaments stretch thinner, and galaxies retreat into isolated pockets of survival. The future of the universe is not one of bright clusters, but of increasing silence. Scientifically, void expansion will continue to accelerate relative to the denser regions. Filaments will thin, clusters will stop merging, and gravitationally bound structures will become islands floating apart. Eventually, even star formation will cease as gas supplies dwindle. The universe will grow cold and dark, moving toward thermodynamic equilibrium. Visually, it feels like walking through an abandoned city at dawn, the architecture still standing, but the warmth of life slowly fading. And from that quiet cityscape comes a reminder. Nothing in the universe is static, not even emptiness. There is a soft sadness in knowing that even the brightest galaxies will eventually dim. Stars consume their fuel. Gas clouds grow sparse. Supernovae become rare. In isolated regions near void boundaries, these changes happen even faster, accelerating the quietening of the cosmic landscape. Scientifically, simulations show that galaxies in underdense environments will exhaust star-forming material more slowly, but will eventually reach the same fate. Once hydrogen is used up or dispersed, star formation ceases. Over trillions of years, galaxies fade into populations of cooling remnants. White dwarfs are neutron stars, and long-lived faint stars burning slowly in the dark. Visually, it is like watching a campfire burn low as the night deepens, embers glowing faintly until they cool into ash. And from that dying fire comes a thought. Endings are woven into the universe's fabric from the beginning. There is something quietly beautiful in realizing that, despite the vastness of the cosmic void, life arose here, on a small planet, orbiting a modest star, in a galaxy drifting through an underdense region of the universe. The emptiness did not prevent life. It provided the space for it to exist without overwhelming disruption. Scientifically, the stability of our region may have been beneficial. Our galaxy's position away from cluster cores reduces exposure to radiation, collisions, and disruptive gravitational interactions. The relative calm of our neighborhood allowed star systems to form and persist long enough for life to emerge and evolve. Visually, it feels like finding a small garden growing in the center of a quiet courtyard, protected, peaceful, nurtured by the absence of chaos. And from that garden comes a reflection. Life finds room where the universe gives it silence. There is melancholy in realizing that the cosmic void through which we drift may outlast everything familiar. The stars, the galaxies, even the atoms themselves. Over unimaginable timescales, matter may decay, black holes may evaporate, and the universe could fade into a thin, quiet field of cold particles drifting without light. Scientifically, this far-future scenario is known as the heat death or big freeze. As expansion accelerates, energy becomes more spread out. Stars die, black holes evaporate by Hawking radiation, and entropy reaches maximum. The universe becomes a thin, cold sea of structureless particles, with voids expanding into nearly absolute emptiness. Visually, it resembles the last snowflakes melting on a warm stone, delicate, temporary, fading into nothing that remembers them. And from that fading comes a soft realization: even the universe is a story with an ending. There is a quiet comfort, however, in knowing that none of these endings diminish the beauty of what exists now. The night sky above, the galaxies that still shine, the cosmic structures still forming. All of it is real, immediate, and breathtaking. The future's silence does not erase the present's wonder. Scientifically, the current epoch is one of richness. Star formation continues, galaxies interact, clusters evolve, and large-scale structure remains dynamic. Void boundaries shift, filaments stretch, and cosmic flows reveal the interplay of dark energy and gravity. We live in a time when the universe is still writing chapters, not closing them. Visually, it's like standing on a hill overlooking a vibrant landscape, aware that winter will come someday, but grateful to witness the colors of autumn before the frost. And from that landscape comes a reminder: beauty does not need to last forever to matter deeply. All these realizations, the shrinking horizon, the fading galaxies, the future cold, the present richness, the protective quiet of our cosmic location, create a gentle emotional truth. Drifting through a void is not a sign of insignificance. It is a sign of belonging to a universe so vast that it makes room for everything: silence, light, beginnings, endings, and the fragile thread of consciousness that observes it all. And as that awareness lingers softly, like a last echo fading through an empty hall. Another deeper question begins to rise, one that leads us further into the quiet heart of existence itself. There is a quiet weight that settles on the mind when you contemplate how the universe will eventually forget us. Not out of cruelty, but simply because time stretches so far beyond our short-lived presence that even the grandest human achievements become brief sparks in a dark ocean. Drifting through a cosmic void amplifies that awareness, the sensation that we are part of a story whose scale makes our chapter feel impossibly small. Scientifically, humanity's biological timeline represents an almost invisible moment within cosmic history. Stars lived and died long before Earth existed. Galaxies collided, merged and evolved over billions of years without any witness. The large-scale structures we study today began forming when Earth's crust was still molten. The void we travel near existed before life took its first tentative steps on land. Visually, it feels like standing on a cliff at dusk, watching the last bit of sunlight slip beneath the horizon, leaving the world bathed in a soft, contemplative gray. And from that fading light comes a reflection. Insignificance and beauty often walk hand in hand. There is sorrow in realizing that the universe keeps no permanent record of us, not our languages, not our cities, not our thoughts. Even the atoms that form us were borrowed from earlier stars and will eventually be returned to deeper forms of emptiness. We are temporary arrangements of matter passing through an ancient structure we barely understand. Scientifically, matter cycles through stars, planets, and interstellar gas. Over long enough timescales, even stable nuclei decay or are disrupted by cosmic processes. The universe does not preserve specific configurations. It prefers constant transformation. Structures rise and fall according to the quiet rhythms of gravity, fusion, and entropy. Visually, it resembles a sandcastle on a vast beach, intricate, deliberate, meaningful for a moment, but destined to be smoothed away by the next high tide. And from that smoothing tide comes a gentle truth. Impermanence is the price of existence. There is a deeper ache in acknowledging that even our galaxy will not survive forever. Its stars will dim, its arms will unravel, and the gravitational bonds that hold it together will fray over extraordinary timescales. Eventually, only remnants, white dwarfs, neutron stars, fading embers, will remain, drifting inside a void that has grown even larger. Scientifically, stellar evolution predicts that most stars will exhaust their fuel, contracting into remnants. Galactic gas will be depleted, preventing new stars from forming. Over trillions of years, gravitational interactions will scatter stars, dissolving galactic structure. The Milky Way's identity will evaporate into a cloud of faint points, slowly dispersing into darkness. Visually, it is like watching the pages of a book loosen and fall away one by one, until only fragments remain on the table. And from those scattered pages comes a thought. Even the grandest structures can fade quietly. There is melancholy in knowing that humanity's entire existence plays out within a cosmic landscape overwhelmingly defined by emptiness. Stars, planets, and galaxies are the exceptions, brief concentrations of matter suspended in a sea of near-nothingness. And yet, it is within this near-nothingness that consciousness emerged and began asking questions about its place in the dark. Scientifically, the baryon to vacuum ratio shows that visible matter makes up less than 0.5% of the universe. The rest is dark matter and dark energy, neither of which emits or absorbs light. Voids dominate cosmic geometry, making the universe a collection of islands separated by distances too large for light to traverse in a single cosmic age. Visually, it feels like sailing across a black ocean with only a handful of distant lighthouses marking the horizon. And from those distant lights comes a reflection. Rarity intensifies meaning. There is a quiet humility in realizing that consciousness, the ability to reflect on the universe, is itself incredibly fragile, a thin veil of biochemistry, a delicate balance of atoms, an improbable arrangement of molecules. And this fragile spark exists in a universe whose scale dwarfs every thought it contains. Scientifically, the emergence of consciousness depends on precise chemical conditions and environmental stability. Life requires narrow temperature ranges, protective atmospheres, stable star output, and countless evolutionary steps. The cosmic void surrounding our region provided a relatively calm neighborhood for these conditions to develop undisturbed over billions of years. Visually, it resembles a single candle flickering in a cavern the size of a continent. And from that fragile flame comes a quiet understanding. The universe doesn't need life to be beautiful, but life needs the universe to be calm. There is a deep stillness in contemplating the quiet future of existence. As galaxies fade and stars die, the universe will become increasingly dominated by emptiness, a quiet expanse where little changes and where time flows without events to measure it. Consciousness may disappear, leaving behind a silent cosmos drifting through infinite night. Scientifically, this aligns with the predicted heat death scenario, where entropy increases until usable energy is exhausted. The universe becomes near uniform in temperature, structure dissolves, and even atomic nuclei may eventually decay. In such a future, voids expand into near total emptiness, their boundaries irrelevant as everything cools into stillness. Visually, it is like snow falling slowly in a vast, abandoned plain where no footsteps remain. And from that silent snowfall comes a reflection. Endings can be peaceful even when they are absolute. There isn't, however, a paradoxical comfort in recognizing that our awareness of the universe's fragility gives us reason to cherish what exists now. The stars still shine, the galaxies still dance, the cosmic web still flows with energy and form. We live in a brief era of structure, light and life, a window where the universe is vibrant and awake. Scientifically, this is the stelliferous era, the cosmological epoch when stars continue to burn and matter remains organized. It is a relatively short phase in the universe's long career, but it is the one in which observers like us can emerge, wonder, measure, and reflect. Visually, it is like standing on a mountaintop during the last golden hour of the day, aware that the sun will eventually set, but grateful for the warmth while it lasts. And from that golden hour comes a truth. The value of a moment is not diminished by its impermanence. There is a quiet tenderness in accepting that the universe does not revolve around us. It does not adjust itself to our needs or tailor its structures to our survival. And yet, through a combination of cosmic chance and natural law, we arose in a place calm enough for life to flourish, a quiet bubble of stability drifting along the edge of a void. Scientifically, this perspective is reinforced by the anthropic principle, which acknowledges that conscious observers arise only in regions where conditions allow complexity. Our cosmic location, neither too dense nor too isolated, provided just enough stability to foster evolution across billions of years. Visually, it resembles a lone flower blooming in a field of frost, delicate, improbable, and temporary. And from that fragile bloom comes a realization: meaning does not require eternity, it requires awareness. All of these contemplations, fading galaxies, fragile consciousness, quiet futures, improbable beginnings, and the immensity of emptiness bring us to an emotional truth that echoes softly through the universe. We exist not despite the cosmic void, but because of it. Our place is small, but it is real, Our time is brief, but it is ours. And as that understanding moves gently through you, like the last note of a distant melody, another question begins to form, one that leads us into the quiet resolve and gentle acceptance awaiting in the final chapter of this cosmic journey. There is a quiet reconciliation that comes when you finally accept how enormous, how ancient, and how indifferent the universe truly is. Not hostile, just vast beyond comprehension. Drifting near a cosmic void brings this truth into focus, inviting a sense of calm that grows from understanding rather than fear. The emptiness feels less like absence and more like space for reflection, like the universe giving you room to breathe. Scientifically, cosmic voids model the large-scale environment of the universe with clarity that denser regions cannot match. Their simplicity allows cosmologists to study expansion, dark matter distribution, and the structure of space-time without the complications of intense gravitational fields. They provide baseline conditions against which the broader universe can be compared, revealing subtle deviations and confirming key cosmological principles. Visually, a void resembles a quiet valley at night, where the air is still, the sky wide, and the silence deep enough to hear your own heartbeat. And from that still valley comes a thought. Clarity often lives in quiet places. There is peace in recognizing that the universe needs both fullness and emptiness to exist as it does. Galaxies require voids to shape their motion. Filaments form only because empty regions give them space to stretch. Even cosmic evolution relies on contrast, on places where matter gathers and places where it does not. Scientifically, simulations of large-scale structure formation demonstrate that void growth is crucial for the cosmic web's stability. As voids expand, they drive matter toward filaments and nodes, enhancing structure formation. This interplay ensures the universe evolves with balance, preserving statistical homogeneity and isotropy across vast distances. Visually, it resembles the spacing between musical notes, where silence defines the rhythm that gives the melody meaning. And from that cosmic rhythm comes a realization: nothing can be understood without its opposite. There is a gentle acceptance in knowing that the universe does not promise permanence. Everything we see, stars, galaxies, clusters, even the cosmic web itself, is temporary. Yet this impermanence doesn't diminish their worth. If anything, it enriches it, lending urgency to the wonder we feel when we look up at the sky. Scientifically, entropy dictates the long-term trajectory of all cosmic structures. Energy diffuses, matter spreads, and order gradually dissolves. Stars burn through fuel, galaxies collide or fade, and gravitational structures evolve into simpler forms. The cosmos is dynamic, ever-changing, and destined to wind down over unimaginable timescales. Visually, it is like watching a river carve through stone across centuries, change so slow you cannot see it, yet undeniable when you step back and observe the whole. And from that river-carved landscape comes a reminder: beauty lies in motion, not permanence. There is something calming about understanding that our galaxies drift through a void is not chaos, but choreography. Our motion is part of a larger pattern, a graceful flow shaped by gravitational influences stretching across hundreds of millions of light years. The universe has been refining this motion since long before Earth formed. Scientifically, the combination of void expansion, filament attraction, and supercluster gravitational pull defines the Milky Way's peculiar velocity. Data from the cosmic microwave background, dipole, redshift surveys, and gravitational flow reconstructions reveal a coherent motion influenced by both overdense and underdense regions. It is not random, it is structural. Visually, it resembles a small boat gliding along a wide, slow-moving river, carried gently by currents shaped far upstream. And from that drifting boat comes a thought: we are always moving, even when we feel still. There is comfort in realizing that emptiness is not nothingness. It is a framework, a background, a canvas upon which the universe paints its brightest lights. Without voids, galaxies would have no room to grow. Without silence, sound loses meaning. Without darkness, stars cannot shine. Scientifically, voids host faint dwarf galaxies, primordial gas, and delicate dark matter networks. They are not vacant, they are simply gentle. Their low-density environments create unique laboratories for understanding galaxy formation, cosmology, and the interplay of forces that define cosmic evolution. Visually, it's like the negative space in a painting, the area that allows the image to breathe, the quiet that gives the colors room to glow. And from that negative space comes a realization: emptiness gives form to everything. There is a profound sense of belonging that emerges when you acknowledge that we are not separate from the universe, but inseparable from it. The atoms in your body were forged in stars. The energy that fuels your thoughts was once cosmic radiation. Even your sense of self rests on physical processes shaped by the expansion of space. Scientifically, the elements comprising life, carbon, nitrogen, oxygen, iron, were created in supernovae and stellar fusion cycles. Quantum fluctuations in the early universe seeded the distribution of matter that eventually formed galaxies, including ours. Consciousness arises from structures shaped by cosmic evolution stretching back to the Big Bang. Visually, it feels like tracing your ancestry not through family trees, but through constellations. And from that star-bound lineage comes a quiet pride. We are temporary, but we are made of eternity. There is a deep calm in accepting that we do not need to solve every cosmic mystery to appreciate the universe. Some answers will come with time. Others will remain just beyond reach, shimmering like distant galaxies drifting across the edge of the observable horizon. Wonder does not require certainty, it requires presence. Scientifically, unresolved phenomena, dark energy, cosmic void anomalies, large-scale flows, represent active areas of research. Our understanding evolves as new instruments and surveys refine measurements. Yet even incomplete knowledge reveals profound insight into cosmic structure and behavior. Visually, it is like watching snow fall from a window, each flake a question, each drift a possibility, and the beauty lying not in counting them, but in witnessing them. And from that quiet snowfall comes a reflection. Curiosity is a form of peace. All of these realizations, balance, impermanence, motion, connectedness, belonging, and the power of unanswered questions, bring the cosmic void into sharper emotional focus. It is no longer a place of absence, but a place of perspective, a reminder of scale, time, and the fragile wonder of being conscious inside such immensity. And as that understanding settles gently within you, like soft dust drifting onto a still surface, something begins to glow faintly in the dark, a final thread leading you toward the quiet resolution waiting in the concluding part of this journey. There is a delicate sadness that drifts in when you contemplate how much of the universe will remain forever unknowable. Not because we lacked curiosity, not because we stopped searching, but because the universe itself places limits on what can be witnessed. Drifting along the edge of a cosmic void brings this truth into focus, reminding us that we are travelers with lanterns too small to illuminate the deepest corridors of existence. Scientifically, the cosmic horizon defines the boundary of observable reality. Beyond this limit, the expansion of space outpaces the speed of light, carrying distant galaxies away faster than information can reach us. No future technology can bridge that gap, as the barrier arises from space-time itself. Our cosmic address is bounded not by walls but by geometry. Visually, it's like standing on a foggy shoreline where waves disappear into grayness, leaving you unsure where the sea ends and the sky begins. And from that blurred horizon comes a reflection. The unknown is not our failure. It is the universe's quiet boundary. There is a soft ache in realizing that even the stars we see tonight are only memories, their current forms hidden behind light years of distance and time. Some may have dimmed, flared, or vanished entirely by now. The sky we trust as a map is, in truth, an archive. Scientifically, starlight takes years to reach us, and the farther a star is, the older the information we receive. A star 1,000 light years away is seen as it was a millennium ago, long before modern human history even existed. The deeper we look into the void, the older the universe becomes, unfolding in reverse. Visually, it feels like flipping through old photographs, beautiful, frozen moments that no longer represent the present, and from those ancient images comes a gentle truth. All light is a form of longing. There is a quiet melancholy in understanding that even consciousness itself is temporary, not just for individuals, but for civilizations. The universe does not guarantee continuity. It offers the conditions for awareness, but does not promise its preservation. The cosmic void reminds us of this fragility through sheer scale. Scientifically, complex life requires precise conditions: stable stellar output, chemical diversity, long planetary habitability windows. These windows eventually close as stars age, atmospheres erode, and orbiting bodies shift. Civilizations, no matter how advanced, are limited by astrophysical timescales that far exceed biological ones. Visually, it's like a candle flickering in a vast cathedral, bright enough to fill a small corner, but powerless to alter the structure around it. And from that flickering flame comes an insight. Awareness is a brief shimmer on the long surface of time. There is something bittersweet in noticing that even our galaxy's journey through the void feels like a farewell, a slow drift away from regions rich with light toward deeper stretches of cosmic quiet. It is not a dramatic journey, but a gentle one, guided by the soft pull of gravity and the silent expansion of space. Scientifically, the Milky Way's peculiar velocity reflects interactions with both overdense and underdense regions. As voids expand and clusters evolve, galaxies shift relative to the cosmic web. Our path through space traces a trajectory influenced by ancient distributions of matter set in motion shortly after the Big Bang. Visually, it resembles wandering down a long, empty hallway where each step echoes faintly behind you, while the darkness ahead remains calm and steady. And from that hallway comes a realization. Movement is not always progress. Sometimes it is simply passing through. There is a quiet sadness in recognizing that everything familiar, the constellations, the patterns of stars, the shape of our night skies, is temporary. Over millions of years, stellar motions will rewrite the patterns until the sky becomes unrecognizable. We will be gone long before that happens, but the melancholy lies in knowing change is inevitable, even without witnesses. Scientifically, stars in the Milky Way orbit the galactic center at different speeds. Over time, constellations distort, dissolve, and reform into new shapes. The night sky is a dynamic tapestry, though the changes are too slow for human lifetimes to perceive directly. Visually, it's like a mural slowly fading under centuries of sunlight, the colors drifting into softness until the original image becomes memory. And from that fading mural comes a reflection. Permanence is an illusion built on the limits of our perception, there is a strange comfort in realizing that emptiness itself can be protective. The cosmic voids that feel lonely from a philosophical perspective are, scientifically, some of the safest and most stable environments in existence. Few catastrophes unfold there, and the slow, gentle evolution within void galaxies contrasts sharply with the chaotic lives of cluster galaxies. Scientifically, void galaxies experience fewer mergers, less stripping, and minimal tidal disruption. Their isolated environment protects fragile disks, allowing stable rotation curves and extended star formation histories. The quietness of void regions fosters longevity rather than decay. Visually, it's like a house standing alone in a quiet countryside, far from the noisy bustle of crowded cities. And from that lonely house comes a realization: solitude is not always emptiness. Sometimes it is safety. There is a soft longing in contemplating the future, when the universe becomes too stretched, too cold, and too dim to support structures like those we know today. That distant epoch is not a threat to us. We will be long gone. Yet imagining it evokes a gentle melancholy, as if witnessing the last chapter of a story written in starlight. Scientifically, the Big Freeze scenario predicts the eventual decline of all energy sources. Star formation will cease, galaxies will fade, black holes will evaporate, and the cosmos will approach thermodynamic equilibrium. Void regions will dominate fully, their emptiness extending across nearly all cosmic volume. Visually, it is like imagining a library slowly emptying until only dust motes drift between forgotten shelves. And from that empty library comes a thought. Endings can be quiet and still be profound. There is tenderness in accepting that our awareness of these distant futures does not diminish the beauty of the present moment. If anything, it sharpens it. The night sky above you tonight is vibrant, precisely because it will not last forever. Its impermanence lends weight to its wonder. Scientifically, we live in an era of stellar richness, cosmic structure, and visible galaxies. Our horizon is crowded with light, compared to what it will be in the far future. Observing the universe now is witnessing it in its youthful vibrancy. Visually, it feels like watching autumn leaves fall, knowing winter will come, yet appreciating the color while it is here. And from those falling leaves comes a truth: beauty is the child of transience. There is melancholy, yes, but also gratitude in recognizing that the universe allowed us to exist at all. Out of all the possible places, times, and configurations of matter, we arose in a quiet corner where life could bloom, consciousness could reflect it, and curiosity could unfold into meaning. Scientifically, the coincidences required, metallicity, stellar stability, orbiting radii, galactic placement, are extraordinary but natural. They do not imply purpose, yet their confluence enabled life to take root on Earth. Visually, it resembles a wildflower growing in a crack of old stone. Improbable, delicate, and undeniably real. And from that fragile bloom comes a final awareness. Meaning is something we bring to the universe, not something the universe must provide. All these contemplations, memory, impermanence, distance, solitude, safety, and quiet gratitude, drift together into a single emotional current. Drifting through a cosmic void becomes less about emptiness and more about perspective. The void reminds us that our moment is brief but luminous, a single warm spark in a cold ancient sea. And as that spark glows softly in your thoughts, another deeper, quieter feeling begins to rise, the calm acceptance that will guide us gently into the final part of this journey. There is a deep calm that settles in once you stop resisting the scale of the universe and begin to simply rest within it. The vastness no longer feels overwhelming. It feels like a soft reminder that we are part of something immeasurably larger than ourselves. Drifting along the edge of a cosmic void becomes less of a journey outward and more of an unfolding inward, a recognition that existence is vast enough to hold both wonder and quiet acceptance. Scientifically, our place in the cosmos is defined not only by coordinates in space, but by the era in which we exist. The universe at this moment is dynamic, full of structure, and rich with interactions. We arrived during a rare window when galaxies shine. Cosmic webs are visible, and light can still trace the vast geometry of space-time. This era will not last forever, which makes our presence within it all the more meaningful. Visually, it feels like sitting beside a calm lake at night, watching reflections ripple gently beneath the moonlight, aware of their fragility but comforted by their beauty. And from that still reflection comes a realization. Peace emerges when we accept what is, rather than what might have been. There is serenity in witnessing how the cosmic void embraces silence without fear. It does not try to fill itself. It does not yearn for brightness. It simply exists, wide and unhurried, allowing the universe to expand through it without resistance. Observing such quietness teaches something subtle about our own inner landscapes. Scientifically, voids expand, not because they reach outward, but because the universe expands around them. Their emptiness allows dark energy to express its influence more freely. Their calmness isn't passive, it is foundational, shaping cosmic structure through absence rather than force. Visually, it resembles a soft blanket of snow resting on an empty field, where silence becomes a presence rather than a void. And from that snowy stillness comes a gentle thought. Emptiness can be a form of fullness when seen with an open mind. There is a soothing comfort in acknowledging that the universe does not require us to understand every detail. Mysteries are not barriers to peace. They are invitations to humility. The cosmos is vast enough to hold unanswered questions without losing coherence, and we are allowed to rest within that uncertainty. Scientifically, cosmic puzzles persist. Dark energy, dark matter, quantum gravity, the nature of space-time. Yet physics continues to progress even in the face of incomplete knowledge. This speaks to the resilience of the scientific method and the graceful adaptability of human curiosity. Visually, it is like walking through a forest in fog, where shapes blur and paths soften, yet the journey remains beautiful despite the lack of clarity. And from that fog comes a reflection. Understanding is precious, but not required for awe. There is a gentle lightness in realizing that nothing in the universe is expected to last forever. Not stars, not galaxies, not civilizations. And that impermanence is woven into the beauty of all things. The cosmic void reminds us that permanence is not the measure of worth. Presence is. Scientifically, astrophysical cycles are defined by formation, evolution, and decay. Even the heaviest elements break down. Even black holes evaporate. Over enough time, every structure dissolves into simpler forms. The universe does not cling to its creations, it lets them transform. Visually, this resembles blooming flowers scattering their petals on the wind, brief, delicate, and entirely natural. And from those drifting petals comes a soft understanding. Letting go is part of the universe's rhythm. There is harmony in accepting that the emptiness around us is not a threat, but a reminder that space exists for us to reflect, breathe, and simply be. The void is not hostile. It is neutral, a vast canvas on which the universe paints with gravity and light. In that neutrality, there is freedom. Scientifically, voids create the contrast that allows cosmic structure to form. Their presence is essential to the distribution of galaxies. the shape of filaments, and the stability of cosmic flows. Without emptiness, there would be no architecture, only undifferentiated density. Visually, it feels like hearing a single piano note echo through a quiet hall, where silence shapes the sound into meaning. And from that echo comes a thought. Stillness is not the absence of motion, but the space in which motion becomes visible. There is deep peace in admitting that we do not need to leave a cosmic legacy to matter. Our significance is not measured in universal terms, but in the gentle, immediate truth of experiencing existence. Being here, conscious, aware, briefly alive, is its own form of meaning. Scientifically, consciousness is an emergent property of complex systems, a delicate synthesis of chemistry, biology, and physics. It is rare, fragile, and precious. Its value is not diminished by its temporary nature. Visually, it resembles a lantern glowing softly in a large, dark room, illuminating only a small circle, but illuminating it completely. And from that lantern's glow comes a reflection. Meaning doesn't require magnitude. It requires presence. There is profound tranquility in realizing that drifting through a cosmic void is not a journey into emptiness, but into perspective. The void gives scale to our experiences, context to our fears, and spaciousness to our thoughts. It reminds us that the universe is vast enough to hold our questions, losses, hopes, and quiet wonders. Scientifically, the expansion of voids reveals fundamental truths about dark energy, cosmic geometry, and the evolution of structure. But on a human scale, these same voids reveal something gentler, a sense of peaceful proportion. Visually, it feels like lying beneath a night sky so open that the darkness becomes a comforting blanket rather than an intimidating abyss. And from that vast blanket comes a realization. We belong to the universe not through understanding, but through being. All of these contemplations, acceptance, clarity, quietness, presence, perspective, and unconditional belonging, settle like soft dust on the mind, calming it, grounding it, preparing it. You begin to sense that the journey is reaching its emotional resonance, the point where wonder transforms into gratitude. And as that gratitude glows softly inside you, the path toward the final chapter of this voyage becomes illuminated. There is a soft calm that settles in once you've carried your thoughts across the vastness of a cosmic void and returned with a quieter heart. The universe no longer feels like a cold expanse, indifferent to your existence. It feels like a wide, open landscape where silence has meaning and distance offers perspective. All the mysteries we explored, drifting galaxies, expanding emptiness, ancient light, are still out there, unchanged. But something in you has shifted. You're no longer staring into the void. You're floating with it. As you rest here at the edge of this journey, the immensity of the universe feels less overwhelming and more intimate. You've walked through its hollows, traced the outlines of silence, and let the scale of everything reshape the scale of your worries. The darkness between galaxies doesn't feel empty now. It feels like a place where thoughts can breathe, where time stretches softly, and where the weight of the world becomes lighter with every mile of space imagined. All the science we touched, peculiar velocities, dark energy, cosmic flows, void expansion, blends now into something deeper than data, an understanding that the universe is not chaotic noise, but a quiet conversation between gravity and emptiness, form and space, motion and stillness. You are part of that conversation, made of the same matter that once burned in early stars and drifted through early voids. The cosmos is not distant from you. It is within you. And as you think back on everything, the lonely galaxies, the fragile filaments, the quiet boundaries of supervoids, the ancient light crossing billions of years, it becomes clear that our smallness does not diminish us. It defines the preciousness of our moment. We are temporary, yes, but so is every star, every cluster, every luminous weave in the cosmic web. Impermanence is not a flaw of the universe. It is the rhythm that carries everything forward. There's a peaceful kind of acceptance in knowing that the void we drift through is not a threat, but a cradle. It is the space that allowed galaxies to form, planets to cool, and life to unfold. Without emptiness, there would be no structure. Without silence, no music. Without darkness, no stars. In the quiet of the void, meaning emerges not from purpose but from presence. Your presence, breathing calmly, listening gently, existing briefly in a universe both ancient and newborn. As you settle deeper into this feeling, the boundaries between you and the night soften. You can almost sense the slow drift of the Milky Way, the faint pull of distant filaments, the hush of expansion carrying everything outward. You are here, floating on a tiny planet inside a modest galaxy, drifting through a quiet cosmic valley older than time. And somehow, in all of that vastness, you feel less alone than before. If this journey brought you even a moment of peace, a bit of wonder, or a quiet place to rest your thoughts, I'm genuinely grateful you shared it here tonight. And if you feel like leaving a gentle sign of where you're listening from, what country, what city, what time it is for you right now, I'd love to know. It's a small reminder that even across such a huge universe, we intersect in this one soft moment. Because in the end, this is what ties us together. Light, curiosity, and the quiet companionship of drifting through mysteries larger than ourselves. No one crosses the void alone. We wander together, lanterns in the dark, sharing warmth in the silence between stars. And now, as the last echoes of this story fade, may the night wrap around you like a soft veil. May the quiet feel comforting, not empty. May your breath slow, your thoughts soften, and your heart rest gently in the knowledge that even in a universe vast beyond imagining, your presence makes a small, warm glow, a tiny star in the quiet landscape of time. And someday, far beyond the horizon of this moment, the universe will forget our names. But right now, in this breath, in this drifting, in this silence, you are here. And that is enough.